Hello, everyone. Nice to meet you again. A, B, C, D, E, F, G, H are all one-digit natural number. A and H are not zero. We first line them up in order, to form one 8-digit number, and then line them up again in the reversed order to form a second 8-digit number. We add those two numbers up, and the summation is x. Can you prove that? X is not a prime number? Why not give a try, and we will come back soon. Let's first calculate this summation. Focusing on the first digits, their summation equals to the summation of A and H, multiplied by 10 million. Focusing on the last digits, their summation is the summation of A and H, multiplied by 1. Therefore, when we put these two summation together, we obtain the summation of A and H, multiplied by 10 million and 1. For the same reason, the summations corresponding to the second and second last digits equal to the summation of B and G, multiplied by 1 million and 10. And the next equals to the summation of C and F, multiplied by 100,000 and 100. And the last equals to the summation of D and E, multiplied by 11,000. Taking a look at those number, we know 10 million and 1 equals to 909,091, multiplied by 11. 1 million and 10 equals to 90,910, multiplied by 11, 100,000 and 100 equals to 9,100, multiplied by 11, and 11,000 equals to 1,000 multiplied by 11. They all have a factor 11. So we prove that this big number must be a multiple of 11, so it cannot be a prime number. So, we make it. However, there is a further question. Why do we immediately know that 10 million and 1, 1 million and 10, 100,000 and 100, and 11,000 are all multiples of 11? In other words, what integers are divisible by 11? Let's take a look at a number with many digits, in a general form like this. We can also give a specified example, like this specified number. We would like to calculate the remainder of this big number divided by 11. First, let's take a look at the first two digits. U, V. In this specified number, this should be 83. If V is not smaller than U, the remainder should be V minus U, otherwise, it should be V minus U plus 11. We call this remainder as L. In this specified number, since 3 is smaller than 8, L should be 3 minus 8, and plus 11, so as to equals to 6. Then we move to the next digit, and invest the two-digit number, L, W. In the specified number, this two-digit number should be 62. We calculate the remainder of the new two-digit number divided by 11. When W is not smaller than L, it should be W minus L, otherwise, it is W minus L plus 11. And we call this new remainder as M. From the viewpoint of the original number, M should be W minus V, plus U, and plus a multiple of 11. In the specified number, M should be 2 minus 6 plus 11. From the viewpoint of the original number, which is in fact 2 minus 3, plus 8, and plus 11, times the difference of 1 and 1. So it equals to 7. We can move on to the next and next digits. The final remainder is there. The last digit, minus the second last digit, and plus the third last digit, minus the fourth last digit, plus the fifth last digit, until the first digit, and plus a multiple of 11. Therefore, if the original number is divisible by 11, this remainder should be equal to 0. Let's say, we have a 6-digit number, U, V, W, X, Y, Z. We can separate the odd and even places, and add up those digits, separately, and call the summations as P and Q, respectively. So whether the 6-digit number is divisible by 11 is equivalent to whether the absolute value of the difference between P and Q is divisible by 11. In the specified example, we separate the odd and even places, calculate their summations, and find they are both 18. The difference between them is 0. So it is divisible by 11. In fact, the quotient is as big as 7,567,785. Getting back to the previous question. Why are those numbers all multiples of 11? Because in each number there is only one non-zero digit at the even place, and one at the odd place, and they are both 1. Therefore, the difference between the summation of even position digits and the summation of odd position digits is obviously 0. So we know they are all multiples of 11 at the first glance. That is it. Thank you for watching, and see you next time.